because it is starting to fill up. I want to see, are these vapors flammable? Because in the past, the vapors are only flammable after the machine's been running for like 30 minutes because it has to heat up quite a bit. You said, would moving the bucket away help for better condensing? I don't think so. I don't think that would do anything. Yeah, the vapors are coming out at a crazy fast rate. A very quick rate. I don't think I could even light it because they're going to blow themselves out. Can the machine get too hot? No, the machine really can't get too hot because, you know, like I said, the outside is always hotter than the inside. So I've never experienced the machine getting so hot that it starts to damage the metal. This is not really an issue with microwaves. But if I do want to regulate the temperature, all I have to do is turn off magnetrons, right? I could just run 2 magnetrons less. You know, it's a pretty simple temperature control situation. The only issue is it's almost impossible to know the temperature inside. Latoria, what's up on YouTube? That's the only issue, guys. We can control the temperature, just turn off some magnetrons. But we can never know what the true temperature is on the surface level of the plastic with the microwaves, because microwaves heat from the inside out. So it's just not possible. At least without some very sophisticated technologies. What's up, Zai myself? What's up, Craig? Said, an idea is to shoot the gas it emits to a wind turbine to get energy. Well, you know what? That's how natural gas plants work. They have the natural gas turbines, which shoot it in and burn it. So it's like a jet turbine, right? You know, so a turbine is way more efficient than a generator, but turbines have to be built huge for them to work like that, and they're very expensive, so that's not going to be realistic for me. What's up, Solidas on Instagram? I appreciate you, man. You said, what is your opinion on the current development of AI? I think it's terrifying. Well, I mean, like, you know, think about it like this, guys. We made plastic. Plastic was a magic product. It was so good that we made so much. And all we focused on was making everything out of plastic as much as we could, as quick as possible. But we didn't for 1 second think about, what are we going to do with all this plastic on the other end? We only focused on the pros, not the cons. And then what ended up happening, we made too much plastic, we don't know what to do with it, and now we have to come along doing all this crap to make a solution for it. But yeah, that's the thing about the AI. I think that it's just, we're told to make the Terminators, but we're not trying to develop the Terminators that are going to fight the Terminators. We're too focused on developing the AI itself. So that's what's going to happen. It's going to be too late, too. You said, have you thought of an alternative energy to replace the microwave? The only other thing I've thought about is induction. But inductive heating. But, you know, right now, I've been doing the microwaves for years, so I'm just kind of going all in and seeing where we're going to go. Right? Seeing how far it's going to work. Oh, wow. So we're definitely getting real heat going into this thing. Because I can actually see something on this first quarter of the machine is actually smoking. It's not a leak, but I think it's paint on the machine. It's smoking because it's very hot. Yeah, it's radiating. I can feel it. Yep, the columns are very much heating up. What's up, the Empire's podcast? What's up, man? So the columns are very much heating up, guys. So That means, you know, right now it's looking like it's just a matter of time until we get oil coming out the other end. If I had this thing insulated, we probably would have oil by now. Can you explain what pyrolysis is? I just want to understand what's happening in the machine. Yeah, sure. So what is pyrolysis? Well, pyrolysis is when you heat something up in the absence of oxygen to break it down. Now, I'm using plastic, but anything organic works, right? So in pyrolysis, what happens is, in this machine, I put in plastic, right? Suck out all the oxygen. So no air, no oxygen can be in there, right? And after I do that, I heat it up. So when you heat something up without oxygen, it cannot burn or catch on fire. So when these microwaves go in this machine and heat up the plastic, since there's no oxygen, it does not burn. Instead, it breaks down under the heat. The word pyrolysis means pyro and lysis. Pyro means heat, lysis means to break apart in Greece. Okay? In Greek. So what ends up happening is the plastic breaks down to its basic chemical components. Now, plastic comes from crude oil, right? It is a product of crude oil. Crude oil also makes all of our fuels of this world, right? So since plastic is a product of crude oil, that means it has crude oil in it. And crude oil has every single fuel in this world in it. So all we're doing is reverse engineering the plastic, extracting all those fuels in the plastic out. And we're doing that by heating it up without oxygen. And like I said, it's not limited to plastic. It'll work on wood, it'll work on grass, it'll work on anything organic, okay? You said, get old hot water tanks, insulation. Oh, that's true, that's a good idea. You have a question? What's your question, Oliver, on Facebook? So you said, so you basically melt plastic using heat? Well, it's similar to melting plastic, but it does more than that. So it melts the plastic first, but then it does something else. After it melts the plastic, it breaks it down again. It completely vaporizes the plastic. But when it turns the plastic into a vapor, it breaks it down on a chemical level. So the plastic is no longer plastic. So this natural gas we're getting out is not plastic natural gas. There's no plastic in it. There's no microplastics in it. It is chemically a completely different product. It's like if you take a piece of wood, you set the piece of wood on fire, and you have smoke come off from that piece of wood. Is that smoke wood anymore? No, it's a completely different product. It's a permanent chemical change, and that's exactly what we're doing here. So that's why my fuels have no plastics in them. My natural gas has no plastic in them. And then all the stuff of the plastic in the machine, when the machine is done, is carbon, right? So that solid carbon has tons of uses as well. It could be used as biochar, as fertilizer. It could be used as a concrete filler. So it turns the plastic into crude oil vapor. Exactly, Zach. So those magnetrons looking juicy today. Yeah, the machine is really looking good. It's always looked like a reactor ever since I added all the pipes to it. But now that it has this line of magnetrons, goodness gracious. It looks like a beast. And we still got so much more. All these magnetrons you see are only half as much as we're going to add, right? Only half. So you guys see Yoga Ball's filling up. You've been watching it live. It started off dry, now it's a complete ball now. And it's almost actually full. Not quite, but it's getting there. But you see it happen live. You saw it. We started live, it was empty. And how is it on YouTube? Is it laggy at all on YouTube, guys? Is it laggy on YouTube? Oh, are we good there? Take a look at it. You see it. You've seen it here. You've seen it here. Before your eyes. Not laggy? Cool. Good to see. So we have not spun the blades yet. You said, can we get a walk around? That's going to be very difficult. because I don't have a cameraman. I'm live on 3 things right now, and they're connected with Ethernets. So it's not going to be easy to give a walk around it. And I personally don't like to walk around this side of the machine when it's on. The side with all the magnetrons. That's why I designed this machine this way, where all the electronics are on one side, so I can stay the hell away from that side when it's on. Yeah, it's hot all the way around. The machine is hot in every corner. Ooh. Yeah, even this is hot, which is good. Because if this isn't hot... So let me tell you guys why, under the law of physics and thermodynamics, the whole machine has to be hot for us to get oils. Let me explain, okay, the chemistry behind that. This is... pyrolysis, another name for pyrolysis is destructive distillation. If you ever watched Nile Red, you know what distillation is. Distillation is when you take, it could be a solid, but mostly it's liquids, right? And then you heat up those liquids into a vapor, and you boil over those vapors into a condenser to get out certain fractions. Now this is a destructive distiller because we're not trying to get certain fractions. We're trying to just destroy whatever we put in here, which is plastic. But the issue is, right, unless this whole chamber is hot, let's say we heat up plastics in the back. The plastics turn to crude oil vapor. That crude oil vapor comes to the front. It hits the front, which is cold, and instead of it making oils all the way over here past these pipes where we want the oil, it's making oil inside the machine. Because it's touching this, which is cold, and it's actually transferring its heat into this and condensing off of this. So that's what's been happening to us. Thank you for the badge, Reggio, on Instagram. That's what's been happening to us this whole time. We've been running this machine up to this point because we've had half of the machine hot, not the whole machine. But the thing is, the whole machine in its entirety has to be hot. And microwaves, we use microwaves because they heat from the inside out, which is more efficient. They heat up the plastic, not the metal as much, but we need the metal to be heated up, ironically, for us to get oils. That's the only way we can physically get oils. Let me see who got sent the badges, the stars on the Facebook. Somebody sent stars, but I didn't see it. Oh, here we go. Timothy, thank you for the 100 stars on Facebook. I appreciate you, Timothy. You said, hope the badge helps you in some way. Absolutely, man. Absolutely, Reggio. I appreciate you so much, man. What's up, Kyle? So, look, guys, the yoga ball is almost completely full now. Look at this. Almost completely full of plastic natural gas. Saw what happened live. For the Terps, thank you for the badge on Instagram. I appreciate you. So, now the question becomes, we got our natural gas, obviously we have this production. Should we spin the blades? We have not spun the blades up to this point. Now, need I remind you guys, when you spin the blades, it does raise the pressure in the machine. That's just by the nature of it because there's a whole bunch of pockets the plastic has that are going to be released. So when we spin the blades, we need to hook up a new yoga ball. So that way we don't, you know what I'm saying, just have that pressure build up in there. Because this yoga ball is almost completely like, you see, look at this. Look at this thing, I can sit on this thing completely. I got me a chair now. So, but I got another one, okay? I come equipped. I got plenty of balls. You guys know I got plenty of balls. That's just what I do. Said how to use a natural gas. Well, what I used to do is I used to compress it into a propane tank and then just use it like natural gas to heat up things, cook things. I used it to distill my oils. In this machine, I'm going to use a natural gas to run a generator to run the machine itself, you see? It's an Ouroboros. Let the machine run itself off of the fuels the machine creates, because it creates a sure lot of natural gas. Okay, good news, guys, good news. There are more droplets on the condenser than ever before. Now it's not complete liquid just flowing down like I want to see. But I've never seen this many droplets on the glass. You said, are the gases going to heat the tank? Yes, but not directly. The gases are going to go into a generator, and that generator is going to be what powers all of these electronics. You see? You say you could pull a nice compressor from a refrigerator? I actually have one. I have a big one from an air conditioning unit. I actually use that one to pull the vacuum on this machine. But I probably get a second one. You say, what's the carbon footprint? Well, the carbon footprint is really only up to the electricity, because nothing burns. So as long as your electricity source is clean, this machine will actually have no carbon footprint. Running off of solar or windmills, zero carbon footprint. You have a sample test of the gas to see what color it burns, so you can figure out if it's methane or propane. Yeah, I have a sample. I'll get it. I got some. Yeah, this ball is almost completely full. Let me see if it actually will burn right off of the machine. If not, because it's coming out too quick, I have a ball that we can show. All right, I'm gonna get my other ball to show you it burning, because this one is a little bit too full right now. So this was a ball that we partially filled yesterday. My ball was looking a little bit droopy, a little bit saggy, I won't lie. But this one, we actually lit this yesterday as well. Maybe it might light. Sometimes the flame is invisible too. Sometimes it comes out too quick. But it's burning, the flame is invisible. I can see the heat waves. It's too sunny out here. But sometimes it burns and then the flame is visible. Let me see if I can do something. If I can get it visible. It might not be coming out at enough pressure. I'm not really sure. It's kind of interesting how it works. Sometimes it works great, sometimes it's harder to do. Well, I need to switch this anyway, so let's do that. Let's switch this. Let's switch these balls around, because I got a ball full. In fact, let me see if this will burn. Once again, damn invisible, it's an invisible flame. Gotta do this crap at nighttime. But what does that mean? Okay, so let me ask you, Kyle, because when we do burn the flame, right? When the flame is not invisible, where you can see it, the end of it is orange. All right, I think it's time to spin the blades. Yep, it's definitely time. We got a lot of heat coming in. All right, we're gonna spin the blades. It's always scary to spin the blades, especially now that we have more power going in than ever before. Because, like I say, this is the moment where everything's gonna be put under the test, okay? Because when these blades spin, there's gonna be pressure spikes that happen in the machine. We're gonna spin the blades for a little bit, then we're gonna turn them off. Let us go ahead and spin these blades. I'm just gonna get my my face shield on for safety. All right, so the blade spun. No issues there. We had no leaks, no explosions. It's looking like all my gaskets are holding up well, so that's great to see. Thank you, Lizeth on Facebook. I appreciate you, man. So it looks like everything held up well to the pressure spikes that came from rotating the blades. Once again, I do see a lot of oil droplets on the condensing glass. Matter of fact, let me check the pipe temperature of all the pipes. All right, so the pipes are getting hot. In fact, I'll show you where all the heat is right now, where the heat has traveled. The heat is right here. We need the heat right to here. So it's happening. It's slowly getting there. Once again, insulation. Maybe I should just insulate those pipes, perhaps. That'd be such a small amount. And they really wouldn't hurt much. What's up, Chad, on YouTube? Rapid in fiberglass? Yeah. Yeah, it's very low pressure in the system. But there is some pressure. There is certainly positive pressure in here right now. Especially when we spin the blades. I feel like I smell a leak. Oh, I see. I see what it is. It's a very familiar smell. It's like oil. I can smell oil, but it's leaking out the machine somewhere. And I think I see where. Yeah, it appears that we do have a magnetron gasket that is leaking. I can smell it. Let me turn everything off, because I can smell it leaking. It must have leaked after we spun the blades. It's the latest magnetron I put in there, so it may not have had enough time to set the RCV silicone we use on it. Yeah, the difference is when there's oil, the oil has a much fouler odor than the natural gas. The natural gas smells like a gas station. The oil smells like crude oil. It does not smell good. So I know it when I smell it. It's a very familiar smell to me. Yeah, it's definitely leaking. Definitely leaking for sure. And that's where the oil's coming from too. Ironically, it's leaking oil. It's literally leaking oil. I wonder if I can somehow let me move you guys over there. Maybe you'll see it leak. It's literally leaking oil right now. So that means we were so close to getting oil. I can actually show you the oil stains on the ground in a second. But I'm trying to catch if you see it leaking the oil live. Because I literally just saw a drop of oil leak from this thing before my eyes. That means we were so close to getting oil. So close. Until this dang leak had to happen, of course, right? Okay, so what we're looking at is this. This magnetron here is, it has a leak in this corner. And that leak is actually dropping oil, which is on the ground. Some oil stains. And of course, right now, it no longer wants to leak. It has a little bit of stage fright, apparently. But, we were very close, because what I was explaining to you guys is this is hot, this is hot, this is hot, and all we needed was a little bit more heat further downstream. I mean, clearly the oils are happening. They're inside the machine. There are oils in this machine, but we need them to go over. And that's the issue. They're just in the machine. We need them to go over to our condensing system. They will actually be more pure when they do, because that means that they're being refluxed and rebroken down and actually being, I guess you could say, in a way purified. So by the time we do get them on the other end, they will be cleaner than they are in here. You said, we need energy? Yeah, perhaps. But it seems like we were almost there. It was just a matter of timing. With the size of this chamber, we needed way more power going in to have oil come over quickly. Because it seems like with this, if we just ran it for enough hours, we would have got oil. Because, like I said, I literally saw a drop of oil before my eyes, and the oil drops are down there. I mean, I gotta show you guys individually on each live stream. Let me look. You see on YouTube. So that here, right here. Those are the drops of oil on the concrete. So we are indeed getting oil. So that's a good sign. Look, those are the drops of oil that were coming from right here. So, you know, like I said, perhaps it all happens on purpose. So we may indeed confirm now that we do have oils, but now we need to get them where we want them, right? All right, guys, look on Instagram. Oil drops. Oil drops down below that were coming from right here from this corner, leaking down. Somebody was asking to see the wiring. Well, now this is the perfect opportunity to see the, the power setup. Take a look at all this nonsense. So, was it surprising to see this leak? Not necessarily, because I just put this whole waveguide on today. And since I just put it on today, that means I put the gasket on today. The gasket has RTV silicone in it. The RTV silicone takes 24 hours to set. But I usually find that you can actually run it just fine in under 24 hours. Sometimes microwaves help it set quicker. But sometimes it also doesn't work. So clearly today, it didn't work. You said run off an HVAC capacitor. I'm sure they use these capacitors in HVAC, but these are for microwave ovens. So transformer, capacitor, then magnetron. The magnetrons would actually mix the microwaves. You said, well, the gasket had to work under pressure, and adding any paste, have to make sure it sets or hardens before you can use it. Right. Right, exactly. Matter of fact, guys, you know what we should do? Let's replace this gasket live, because I have to replace it. We're not going to run the machine again, but let's replace it. Now, look how close I am to all these electronics. They're off, but I'm so close. What about if in replacing something happens, it flips on some magic way, okay? You're right here. You're done. I unplug it. I unplug it every time. I don't mess with it. I don't take those chances. So we're gonna replace this live so you guys can, one, see it, how it works, how it goes together, and you can, for two, well, that's pretty much why you want to, so you can see how it goes together. I don't know what else I was trying to say there. Let me get my tools. So we just have to take off a whole bunch of screws. And then, well, first, we take off the magnetron. So let's do that. This is what the magnetron is right here. This is what creates the microwaves. It's still hot, actually. Still very hot, as a matter of fact. We just turned it off. So here it is here. This one was a little bit damaged when I got it from the oven, but this is what creates the microwaves. So next, we take off all, I think it's 12 of these bolts. But you know, this is starting to take the time to do this mess. Oh, and now there's oils getting on my wrench. Can you guys see the oils on there? It actually has a good color to it. It's a little golden. Oh, great. Now it's on my hands, too. Yeah. Well, that's pyrolysis oil right there. So, yeah, we're going to replace this gasket live because I had to wait for it to set anyway. So, even if I didn't do it live, I would have to do it after the live stream anyway. So, it's like, why not do it on the live stream, right? So, I got to do it today, so that way by tomorrow it's set. Maybe we might even see oils under here. That's gracious, this one. I mean, the oils are getting all over my gloves here, I'll tell you that. Oh my goodness, I hate doing this with gloves on. I can't feel anything. I can't even feel the wrench getting on the thing like I want it. There we go. Goodness gracious. This is so difficult with the gloves on. I might take these gloves off. I'm making no progress. Why is it just spinning? Wow, it took how long just to get 2 out? Goodness gracious, at this rate, be here all bloody day. So this thing. I guess we got oil, just not in the way I wanted, right? You better be very specific when you ask for things, they say. You may not get it how you want it, but we get oil all right. And look at it on my bloody hands right here, right? So yeah, it's hit or miss with the RTV. If it's gonna make a good seal if you run it right after you put it on. My last waveguide worked fine. This one did not. But the leak was very small just from this corner, so most of it held up fine. So now we're gonna take it off. So everything actually looks fine. Well, all that probably happens is that the pressure pushed it up, and since the RTV silicone is not set, it had a little bit of flex to it, a little bit of malleability, and it failed. But the good thing about this is, since looking at this, I don't see any cracks on the gasket itself. I can actually reuse this gasket one more time. Just flip it around. Because it's only sealing one side. It's only sealing the side to the chamber. You see all these vapors coming out? Definitely don't want to be breathing that stuff in. You guys can't see it, but there's oils on the surface of this thing. So I'm gonna put my mask on, and what I'm gonna do is wipe off this stuff, put new RTV down, and we're gonna put this gasket on there, the other side. The other side, I know you're probably thinking, well, the gasket is no good anymore, but it's actually fine because only one side is sealing it anyway. So the other side doesn't matter what condition it's in. So now that I got it just pressed on there, I can take my mask off because it's actually sealing it, so none of those vapors are escaping. So now at this point, it's just a matter of torquing it down. You saw we put it on all sides. I put some extra on the corners because the corner was where it failed before. So maybe my my waveguide here, maybe on the corner it has a weak spot, or it's not compressing down completely. So we're trying to counteract that. This is where the magnetron is mounted into. Actually, take a look at this, right? So when I say I built the waveguides, I'm building this part, which is welded onto the chamber, and this part, which is where the magnetron goes. And watch this. You see it down in there? And this, you see, the microwaves reflect into the chamber like that. So anyways, this thing really relies more on compression to seal it than anything. That's why you can actually run it even while the RTV is still setting, because the compression of this alone usually will overcome the very low pressures in the machine. But still, it's always better if the RTV sets. You're never, making it worse by letting it set first. Never. It always performs better and is more reliable if your RTV is completely set before you run it. So I can't be mad at the gasket or the RTV because I ran the machine with letting it set for just an hour, right? So obviously, and on top of that, we're letting it set while the machine is running in a very oil-rich, heat-rich environment. So it's probably the worst possible environment for it to set as well. So, you know, like I said, sometimes you get away with it, sometimes you don't. Today did not. Today was not that day for me to get away with just letting it run. But the good news is we literally saw oils drip. You guys saw the oils on the ground. These pipes getting hot. So tomorrow, you know, I wanted to know today if this was enough power or if I need to build another waveguide. So we have like 3 in the middle, and then we just do like maybe 2 at the end, 3 in the middle, 1 at this end. But I might have to do that Monday because we need to finish this run and see if this is enough to get, you know, oils, right? Maybe it is, maybe it isn't. But we won't know until we figure out. So then, you know, at that point, then we can know the minimum power requirements and the minimum magnetron configuration for this machine to actually operate. And who knows, we still could be under the minimum power requirements. Like I said, this machine is designed to run 12 of them. We're not even well, we are halfway there, right? So, I mean, by that nature, we may not even have enough power going in, but we could. The only way to know, you know, I'm figuring this out just as much as you guys are figuring this out. We're figuring this out together. I've never built a machine this big before. So a lot to learn. Science. This is science right here. You're just learning as you go, figuring out new things, writing off old conclusions, coming up with new hypotheses every time. Just having fun with it as you go along. Of course, the goal is what I've done with my past machines, to have that multiplied by 3. Because that would be brilliant. And we will get there, but maybe perhaps it's not as soon as I had wished. Because like I said, if it is a matter of we are still underpowered, right? Let's say that's the reason why we're not getting the results, right? If we're still underpowered, we just got to wait. Because I got to get some microwave power supplies from overseas, from China. 220 microwave power supplies. These are 120 here. I need 220. Like I run it off of my 220 50 amp circuit, and it will consume way less electricity. I mean, way less amperage. So I'll be able to run way more. I'll be able to run more than just 6. So now you just torque it down, and like I said, this is what really creates the seal. When you torque this thing down, so between this and the RTV setting, I mean, you know, that's why all my other ones have been fine. They don't leak. Because when you have this thing torqued down, and then your RTV is set, it's pretty much immovable. Because my gasket material, you know, I've been doing research. I'm still doing research to figure out what the best gasket is. But that particular material I've been using has been holding up very well to the chemicals, to the heats, to the pressures, to the vacuum. So the material doesn't fail. The only thing that fails, oh, we got some of the silicone is seeping out, but that's actually good. I'd rather have too much than too little, because to be honest, too much is not going to hurt anything, right? In any way. Just as an extra seal, right? Maybe I should have put some extra along the whole bottom side, since the bottom side was where we had our leak. I guess we'll see how this performs. One of these screws did not torque down properly like I wanted it to. Ironically, it was this screw on this corner here, the corner that leaked. So maybe this is why it leaked. It didn't torque down properly. Probably because this one up here isn't either. It's just spinning. Let me see. Okay, so yeah, these 2 screws are spinning, which means they're not torquing down properly, which means they probably will leak. So I'm going to take them out, and I'm going to replace them with some different screws. Because, you know, unfortunately, here's the crazy thing, right? With this machine, a machine this big, with this many, look, we have a machine with 7 of these things, okay? The machine is humongous, 9 foot long, but just one failure shuts down the whole machine. The smallest failure in the smallest spot, but guess what? If I kept running the machine, all the oils I wanted would have been on the ground, not in my condensing system. That's how these systems work. And on top of that, you're polluting. If you keep running it, you have a leak. I told you guys, when this machine operates how it's supposed to, you can breathe fine right next to it. There are no emissions, there are no leaks. I need to expand this hole a bit. I'm going to use a bigger bolt for this corner because it wants to have problems. So it wants to have problems. It's just spinning for some reason. I don't know what's going on, but I think it was doing that earlier too. Because I remember one of these bolts was just spinning on me, and I was like, it's all right, because we have the compression from all the other ones around it, but we had the failure. So clearly it was not all right. So I'll replace it with a bigger one. Hopefully this one will not be spinning on me. Not just because, you know, my metal is not perfect. You know, there we go. I'm a human, so when I cut these things out by hands, sometimes there's little, you know, they're not perfectly flat or whatever, and that could cause issues when it comes to this point here, because when we're torquing this down, we want the surfaces to be kissing each other, you know, completely, as close as we can get. So we need all areas. And that's why we have so many bolts on here, for that reason. So that way, every area possible is completely kissing, completely mating. All right, so now let's install our magnetron back onto here. We got this thing completely torqued down. We're gonna let this set overnight. It'll be fine tomorrow, almost 100% guaranteed. In fact, I don't see a reality where this would possibly fail again now that we solved the issue. So we're gonna mount the magnetron back in. And once again, guys, I keep all the electronics completely unplugged. I don't play with that. I don't mess with them. I don't leave it to chance. Oh, even though it's completely, you know, it's still plugged in, but it's turned off, nothing will flip the switch, right? Surely. No, I don't play with that. I completely unplug it. I don't care. When I'm this close to it, you know, it's just not worth it. Because how long does it take to unplug it? But how long does it take to get shocked and die for good? They almost take the same amount of time. It's almost instant to unplug it. And it's almost instant to get killed, too, by electrocution from this stuff. Actually, it is instant. Damn near. So magnetron's mounted again. Circuit's already done, so I just plug it back in. Now it's done. We got the gasket on. You guys saw what happened live. This is the second time I've done it live, actually. Like I said, it's kind of like, why not? Because I would have gone off live and just did it right after the live stream ended anyway. I wonder, like, you look at that gasket and you're like, why is it like that gasket's weird? You would think that I would just put RTV around the edges. Like, why is the gasket covering the whole thing? It has to be that way because the gasket has to be a material microwaves can go through, right? But the gases cannot escape because you saw this side that we put on here. It's empty. It's open because if it was metal to metal, if it's just a hollow metal sheet at the front, guess what? No microwaves can get in the chamber. So that material that we put on, right? That's a material that allows microwaves to go through it. It's temperature resistant, microwave transparent, once again, chemical resistant, and pressure resistant. So this is what I'm talking about when I say the material sciences of this. Because I have had to do so much research to find that material to use there, for example. And there's a few other materials that work as well, but so far, I'm always doing different ones. People ask me what I use. I'm still trying to figure out what works the best before I recommend anything to anybody. Lead you astray. I used to use fiberglass, but guess what? I found that fiberglass does everything good, but it's not pressure resistant. Once you get up to a high enough pressure, the fiberglass starts leaking in between the fibers. and it's a super small leak, but you guys saw this. This super small leak shut down the whole machine. So super small leaks are unacceptable. It's not. There's a reason why we did so much welding to make sure none of the welds are leaking. Reason why we do so much testing to make sure it's airtight, vacuum tight. So we can't even have a littlest, smallest cornerstone leak. And because guess what? If it's leaking, that's energy we are losing. So we don't want it leaking because now we're losing money. Now you will definitely won't have a leak when I tell you that. You're losing money if you have a leak. That's your energy. You saw it there. Those are oils that were dripping out. It wasn't just, oh, just a leak. No, we're literally losing oils. And those oils were so close. Look how close they were to this pipe system. They were this high up. So they were off the base of the chamber. They were floating. They were in the vapor form. And they were eventually going to start migrating this way. So I really should insulate these pipes. And it would definitely help a lot. But let's see if we got any oil. I don't think we got a drop, but I saw a lot of liquids. A lot of liquid droplets. So we'll see if we got any oils at all. I highly doubt it. As you saw, we were almost at the point with the temperatures to get oils, but then we had, of course, the failure happen right as we got to that point. Ironically, it's not as easy to get oil from this machine as I thought it would be, because it's so big. You know, Mark III, my Mark IV, I mean, not Mark III, but Mark IV was a third of the size of this, and it ran off of 3 magnetrons. So by that math, we would need 9 magnetrons before this thing is operating at the proper temperatures. By that math, right? If we're basing it off of my past machine, which was 3 times smaller than this, we need the same amount. We need 3 times the amount of power on my last machine, which, you know, my last machine had 3 magnetrons. So, you know, let's see. We'll see if we got any oils at all. I highly doubt it, like I said, but you know, if we do, we'll see it live. So all I'm gonna do is just open up this port here. If we have any oils, you're gonna see them drip down into the glass. If there aren't any oils, it'll probably just be a drop, but I don't think there's gonna be any. Nope. You heard the pressure. You heard that pressure leave the machine. So you see it does operate under some positive pressure. No oils today, unfortunately. But the sight glass, it still has a whole bunch of liquid droplets on it. So we were so close. But we're not even getting water coming over. So that lets us know. So we're not even getting water come over. That literally is the straightest way of saying your machine is not hot enough. Right? That's just the simplest way of saying it. So we still got some work to do, but we're going to do another run tomorrow. Another solution could be to just load in way more plastic. I loaded in a lot today. Didn't have the blade spinning, but there's a lot of different variables. So we're going to do another test run tomorrow. This is what science is all about. Trial and error until you figure it out. So I'll see you guys tomorrow. Next test run, 222. All right, guys, you take care. And thank you very much for your support and the donations as well. What's up, Arthur? I'll see you tomorrow, Arthur, and I'll be sure to answer your questions.